Hi, welcome to solveandgo.com. This is the next in a series of videos giving solutions to the final exam, MAT186 from 2005. This is question number 7, which has a couple of different, number of different parts. So it's A through F. Okay, so this will be a longer question. Okay, so we have F and G are continuous functions. And we're given that the integral from 1 to 9 of f of x dx is 6. The integral from 1 to 9 of g of x dx is -4. And the integral from 1 to 16 of f of x dx is 2. Okay, so I'm going to be referring to these values a lot, so you might want to copy them down. So just pause and do that. Okay, so we need to find the values of various different expressions involving integrals. The first one is the integral from 1 to 9 of 3 times f of x plus 2 times g of x dx. Now, the integral is linear, meaning we can split up sums and factor out constant factors. So this is equal to 3 times the integral from 1 to 9 of f of x dx plus 2 times the integral from 1 to 9 of g of x dx, which is 3 times 6. Okay, we know the value of this integral. It's given up here. 3 times 6 plus 2 times -4, which gives us 10. And that's the answer to part A. Okay, let's move on to B. I'll try to keep the values of these integrals up so we can refer to them. B asks for the average value. Okay, so B, average value of f on the interval from 1 to 9. Okay, so sometimes this is denoted f bar. And the formula is it's 1 over b minus a, where a is 1 and b is 9. So it's 9 minus 1 times the integral from 1 to 9 of f of x dx, which is 1 over 8 times this value, which is 6. It's going to be 3 over 4. And that's the answer to part B. Okay, next, part C. Is to find the integral from 9 to 16 of f of x dx. Now, we have the integral from 1 to 9 and 1 to 16. So the integral from 9 to 16 is going to end up being the difference of that. So remember what we have. Okay, so let me write this on the next line. We have the integral from 1 to 16, which we know, of f of x dx, is the integral from 1 to 9 of f of x dx, which we know, it's 6, plus the thing we're looking for, which is the integral from 9 to 16 of f of x dx. So this is just a property of integrals. You can split up the range this way. Let's fill in the numbers we know. 1 to 16 is 2. So we get 2 equals 1 to 9 is 6, and then plus the thing we're looking for, which is 9 to 16 f of x dx. So finally, we get that the integral from 9 to 16 of f of x dx is 2 minus 6, which is -4. Okay, and that's the answer to part C. Part D. So in part D, we're asked for the integral from 1 to 9 of f of x dt. Now, we don't have any integral with respect to t in our list of values up here. But since we're integrating with respect to t, x is constant when we're evaluating this integral. So f of x is also a constant, some function of x. So for instance, if x is a constant, then so is x squared plus 2. Or sine of x, it's just some value. So we can factor constants out of integrals, and this is just the integral from 1 to 9 of the function just 1. Okay, the constant function 1, which is f of x times t, which is the antiderivative of 1, from 1 to 9, which is f of x times 9 minus 1, which is 8 times f of x. Okay, and that's the answer to D. Let's move on to E. E asks for the integral from 1 to 3 of x times f of x squared dx. Okay, so we don't know the integral of f of x squared, but notice that the function inside of f is x squared, and its derivative is 2x, which is essentially here up to this constant factor of 2. So this suggests substitution. So we'd let u equal x squared, then du dx is 2x, and so dx is du over 2x. Okay, let's change our limits of integration as well. So u evaluated at 1 is just 1, and u evaluated at 3 is 9. We just square it. So now our integral is the integral from what's now 1 to 9. We'll leave the x there for the moment. F of u, and dx is now du over 2x. Okay, so the x's cancel, and we end up with a factor of a half out front. And then we have the integral from 1 to 9 of f of u du. Now we know the integral from 1 to 9 of f of x dx, but the difference in the two is it's just the difference in calling the variable x or calling it u. Okay, so there's no substantial difference. We're getting a number out, so the name we give to the variable won't make a difference. Meaning this integral is the same as this one. So we get 1/2 of 6, which is 3. Okay. So, great. Okay, so we get 3. Let's move on to part F. Okay, so part F. Part F asks for the limit as n goes to infinity of the sum as I goes from 1 to n of f of n plus 15I divided by n times 15 over n. Okay, so part F. Now this looks like a Riemann sum. We just have to figure out exactly what function it's the Riemann sum for and over what interval. Well, let's rewrite what's inside F here. Okay, this is 1 plus 15 over n times I. Okay, which means when I is 0, or when I is 1 rather, we have 1 plus 15 over n. When I is 2, we have 1 plus 15 over n times 2, and so on all the way up to when I is n, and in that case it's 1 plus 15 over n times n, so that's 16. So it seems like we're going from 1 to 16. Okay, so also this is delta x here. Delta x is b minus a over n. Okay, so b minus a we also know is 15, which confirms what we just thought we found over here, that the integral goes from 1 to 16. Okay, so it's the interval's length is indeed 15. Okay, so what this ends up being is the integral of f from 1 to 16. Okay, so this equals the integral of f from 1 to 16. And we were given that value, it is 2. Okay, and that's the answer to part F.